there is a pink color ball. Okay, M is denoted in that ball. That is called a central metal atom or central metal ion. See, as you see this module, the central metal atom or ion is occupying the central position of the coordination complex and binds with the other atoms. L, it is represented like L, that is ligand, green color balls, ligands. The next term what we are going to study is ligand. Ligand is nothing but a neutral molecule or an anion which possesses a lone pair of electron. Okay, ligand, the green color ball is what? Ligand. So this ligand donates a lone pair of electron to the central metal ion. You can see in this module. So these ligands are called as what? Lewis bases. Ligands are called as Lewis bases, whereas the metal ion is called as Lewis acid. See, in this module you could see some of the simple ions, anions that act as a ligands. That is, the halides are acting as a ligand. Fluoride ion, chloride ion, bromide ion, iodide ion can be act as a ligand. So the next example you could see some of the molecules can be act as a ligands. Water molecule. So the oxygen atom of water molecule contains two lone pairs of electron. So they donate one of a pair of electron to the central metal ion. Same way ammonia molecule is also act as a ligand. So the nitrogen has a lone pair of electron which is not involved in bonding. That nitrogen donates that lone pair of electron and act as a ligand in this coordination complex. The next example we can see that some of the large molecule can be act as a ligands. Ethane 1,2-diamine. Amine, you know, amine means ammonia. In that ammonia, one hydrogen is removed. NH2 is amine. So in ethane, CH3, from the first carbon, one hydrogen is substituted by an amine molecule, and the second carbon is also a hydrogen is substituted by a amine molecule. So this compound is called as what? This molecule is called as what? Ethane 1,2-diamine. Okay. So the ethane 1,2-diamine is act as a ligand. The nitrogen of amine group donates a lone pair of electron to this central metal ion. Since there are two nitrogen atoms present in this ethane 1,2-diamine, they can donate two pairs of electron to the central metal atom or ion. The next compound what you are seeing in this module is ethylene diamine tetraacetate ion. Ethylene diamine. So the first compound in the large molecule, you can see ethane 1,2-diamine, right? So in this diamine, there are two hydrogens there. These two hydrogen is substituted by acetate ion. What is acetate? CH3COO minus ion is acetate. So this CH2 group is one of the hydrogen is substituted. So CH2COO minus ion is acetate. So EDTA, this ethylene diamine tetraacetate is also called as EDTA. So this can be act as a ligand. This ethane 1,2-diamine and ethylene diamine tetraacetate are called as bidentate ligand or polydentate ligand. Okay, we'll be seeing later this. So depending upon the number of atoms in a ligand that binds to the central metal ion. Okay, central metal ion oda எத்தனை atoms bind ஆகுதோ அதை பொறுத்து the ligands are classified as unidentate ligand, bidentate ligand, polydentate ligand. So let us see these types of ligands later. So in unidentate ligand, the number of atoms in a ligand that binds to the central metal ion in a complex is referred to as denticity. Okay, so here some of the ligands are given, simple ligands, molecules are given here. So chloride ion. See, in chloride ion there is a lone pair of electron. So this acts as a unidentate ligand. That means only one pair of electron can be donated by this chloride ion to the central metal ion. Likewise, water. In water, the oxygen contains, even though there are two pairs of electron, but only one pair of electron can be donated to the central metal atom. Ammonia, nitrogen has a lone pair of electron. Only one pair of electron can be donated to the central metal ion and forms a bond. So these are called as what? Unidentate ligand. So with the help of a diagram you can see the first example, the central metal ion is surrounded by 6 Cl minus ion. All these 6 Cl minus ion donate 6 pairs of electron to the central metal ion. Likewise, this next example, there are 4 water molecules donates a pair of electron to the central metal ion. So the bonding is, you must note, only one bonding is existing between the ligands and the metal ion. The next ammonia also there is a single bond is existing. So these ligands are called as what? Unidentate ligand. That means only one pair of electron is donated to the central metal ion by the ligand and forms a single bond with a central metal ion. That's why these ligands are called as what? Unidentate ligand. The next one is bidentate ligands. See, this bidentate ligand contains two donor atoms. Okay, so that means two pairs of electrons are donated to the central metal ion by the ligands and forms two different bonds with the central metal atom. So in this example, dimethyl glyoxime, the nitrogen of this glyoxime, one nitrogen possesses one pair of electron, another nitrogen possesses another pair of electron. So it is acting as a bidentate ligand. From two different sides, two pairs of electron is donated to the central metal atom. Ethane 1,2-diamine also. In one molecule, there are two atoms can be able to donate a pair of electron to the central metal atom. Oxalate ion is also an example for bidentate ligand. The oxalate ion, oxalic acid, COOH. If H is removed means that is oxalate ion. So the oxide ion of oxalate contains a pair of electrons. Since there are two oxygens of oxalate can be able to donate two pairs of electron to the central metal ion. See the next module, you could see polydentate or multidentate ligands. See this multidentate ligands example is ethylene diamine tetraacetate ion EDTA. So in this molecule there are 6 pairs of electron. It is a single molecule, it is a bigger molecule. Okay, it can donate 6 pairs of electron from 6 different atoms to the central metal ion. So this ligand is called as what? Polydentate ligand or multidentate ligand. This polydentate or multidentate ligands can be called as chelating ligands. So what are the characteristics of chelating ligands? They have lone pairs of electron on more than one atom. They can be capable of binding to the central metal atom or ion through more than one coordinate covalent bond. Such kind of ligands are called as what? Chelating ligands. The next type of ligand is ambidendate ligand. What is ambidendate ligand? See, this kind of ligands have two different type of potential donor atom. Single molecule that contains two different types of potential donor atoms. Okay, so in some covalent compound, one atom may be a donor atom. In other compounds, the next element can be used as a donor atom. See, in this module, you could see nitro group NO2. See, NO2 can be written like this. N is placed at the center. In one side there is a double bond O, in the another side there is a single bond O. In this nitro form, this nitro compound can be, nitro group can be existed as nitrito N and nitrito O. Okay. So what is nitrito N? Here nitrito N means the nitrogen atom donates a pair of electron to the central metal ion. Okay. Such type of ligands are called as what? Nitrito N. In the nitro group, nitrito O group, oxygen donates a pair of electron to the central metal atom or ion is called as what? Nitrito O. You could see the difference. See, nitrito N la metal ion is directly linked with the nitrogen. Nitrito O la metal ion is directly linked with the oxygen, right? So it is a ambidendate ligand. Nitro group is a example for ambidendate ligand. The next example for ambidendate ligand is thiocyanato and isothiocyanato. See, these two ligands are having the same molecular formula, but the donation site is differing. You can see in this module, in thiocyanato, the sulfur atom of the thiocyanato donates a pair of electron to the metal atom. Whereas in isothiocyanato, iso means ultava போயிருக்கு, n இங்க வந்திருக்கு, n இருக்கிற இடத்துல sulfur போயிருக்கு. Okay, so nitrogen donates a pair of electron to the central metal atom. So this is an example for ambidendate ligand.